right, welcome to week 5. So at the end of last week, we did not have time to get to list and set and tuple and dictionary comprehensions. So I thought I was going to have to do a lot of writing to reorganize my notes to account for that this week. So I looked at my notes from the last time I taught the class, and golly, we didn't have time to talk about comprehensions at the end of week 4 then either. So I apparently had already accidentally accounted for that issue. So what we're going to take a look at today is the idea of list and set and dict comprehensions, which are a compact and concise and so-called Pythonic way of defining these collections. I'm also first going to talk about conversion functions that you can use between collections. Anybody have any questions before we dive into this? I did get many questions Sunday and Monday from people about the homework, I think part E or part F or something, which asks you to compute a sum of dollar amounts for various expenses, even when you don't know what the categories are until you look at the data file. And I posted a hint about how you can approach that if that's something that you might be stuck on or that you maybe haven't even gotten to yet. So I hope that's helpful. All right, let's get into this. We've already talked about conversions of fundamental data types, or the so-called low-level built-in data types. We know that if you have a string that is correctly formatted to represent an integer value, that you can use the int function to convert that string into an integer. On the other hand, if the string that you're trying to convert is not in the correct format, in this case, the words 1.5 are not recognized by the float conversion operation, that you get an exception raised. All right, so if I say I get int 1234 as a string, that works fine, and I is now an int. But if I say f gets float 3.7, that's not going to work, and Python is going to yell at me. I get something called a value error exception raised. And in my program, if I were writing a program doing this, I would need to use the try except code to prevent my program from dying at this point. So far, so good? Okay. We can also convert back and forth among the different collection types using collection conversion functions. List to convert things to a list, tuple to a tuple, set to a set, and dict to a dictionary. Let's take a look at a series of examples of how these things are used. If I have an iterable such as hello. Okay, hello is a string, but a string is an example of an iterable. Then I can convert that iterable into a list by using the list conversion function. In this case, the argument string hello is going to be split up into the 5 one-character substrings, HELLO, and so M1 now is a list of those 5 individual characters in that same order. Good. I can also say something like let me say M1A, because I'm not sure what variable names I'm using here. I can say list range 10. Range 10 is an iterable that produces values 0 through 9. So I can use that as an iterable in constructing a list, and M1A now contains It's a list of the 10 values from 0 up to and including 9. If I have a tuple, here I'm defining a tuple manually. T1 gets, and I don't remember what the values were, but let's say 1, 3, 5, 7. All right, so T1 is a tuple. If I want to convert that to a list, I could say list T1, and because a tuple is iterable, this works fine, and I now have a list containing the same items in the same order as my tuple T1. Okay? Let's suppose I have a set, just for gags. So S1, I guess, is, and I'll just put some values in this set, 3, 4, 7, 6, 8, 1, 3, 4, 7, 9. Okay, so there's my set S1, and as we know, the duplicate values were tossed out or ignored, and I can easily convert this set of values into a list, because a set is also iterable. Now, the fact that they came out in the list in the same order that they were stored in the set, I'm not sure that that's something that you can count on for sure, because we know that the items in a set are not guaranteed to be in any particular order. So you wouldn't necessarily want to count on the fact that the values in the list are in the same order that you see when you display the set directly. All right, now you can convert a dictionary to a list, but remember there are many different ways of iterating through a dictionary. You can either iterate on the keys, or you can iterate on the values associated with the keys, or you can iterate on the items, which is the key value pairs contained within the dictionary. Now, because I don't always type so well, I cheated and already created this dictionary N to S. Okay, so N to S here is a 2-month subset of the N to S dictionary that you folks have in your homework. And what it's doing is it's mapping the 2-digit month numbers to 3-character month names. Okay, so if I say N to S sub 01, that gives me back January. By the way, I can use a variable to contain the month string. So here I'm saying ASDF gets the stir value 02, and then if I say N to S of ASDF, I get back February in this case. And of course, if I try to access a value that's not in there, like a key of 03, I'm going to get an exception raised. Key error exception in this case. If I convert this dictionary to a list using the list conversion function, M4 gets list of N to S, well, it didn't complain, but what I get is just the keys, because remember, when you use a dictionary as an iterable, like in a for loop or something, you get the keys out by default. Okay, so it worked, but it only gave me the keys. In fact, I would have gotten exactly the same thing if I had said M4 gets list of N2S dot keys. All right, so either of those ways, I can get a list of the keys that are contained in this dictionary. If I would like to have a list of the values, then oh, I guess, all right, so here on slide 7, I use the dot keys method to get just the keys part of the dictionary. And here we're looking at the values, so I'm saying M6 gets list of N2S dot values. All right, so whereas M4 is my list of keys, M6 is my list of values, and here it is guaranteed that those values will come out in exactly the same order that the keys are in. Okay, so January is definitely the value associated with key 01. February is definitely the value associated with key 02. That's guaranteed. Good. Now, maybe I want both the keys and the values all at once. I can say M7 gets a list of N2S.items. Now, the items iterable returns to me tuples, a sequence of tuples, where the key is the first item in the tuple and the value is the second item in the tuple. So this is actually going to end up creating a list of tuples, a list of two tuples, so to speak. Okay, so it's a list, and here is my first two tuple showing key 01 value January, and my second two tuple key 02 value February. All right, everybody happy with all the list conversions we've done so far? Any questions? Now, here is an annoying thing about all of these list conversion, about all of these conversion functions. You can specify an iterable to do the conversion, but you can't just give a sequence of values. So if I say 1, 2, 3, 4, 5 as arguments, this seems to me to be a design flaw in the Python list data type. You would think it would just do the obvious thing and create a list containing 1, 2, 3, 4, 5. But no. You're only allowed to give one argument, and the argument has to be an iterable. So I get yelled at and told, hey, I expected one argument, but you gave me 5 arguments, and that's not valid. If you did give just a single argument, of course, that also won't work for the same reason. So if I want M8 to be a list just containing the value 4, and I insist on using the list conversion function, then I have to, I don't know, create some iterable containing the 4. Let me create a set containing the 4, and now I've got it. You might have a weird situation in a program where a situation like this arose. Obviously, if you're just doing this interactively, you would just say M8 gets 4 in square brackets and be done with it. All right? I showed you a little bit earlier that range is an iterable, and it's a really convenient one, a really handy one to remember, because if you just want a sequence of integer values, you know, from J to K, whatever that might be, range will do that for you in combination with a conversion. All right, so if I say M sub 10 gets, let me do a different one than what's on the slide, list of range. Let's suppose I wanted 10 through 20. I could say range 10, 21. All right, my final value has to be one past the value that I actually want. So here I have M10 containing the sequence of values from 10 up to 20, but not including 21. And it might be worth reminding you about the step argument as well. I think we've seen that. Maybe not. But let me show you. I can say, give me a range from 10 down to, but not including 0, in increments of -1. Have I shown you this? Have I shown you the step in the range? Okay. So this is going to give me 10 and then 9, 8, 7, 6 down to 1. It won't give me the 0. When I get to the 0, I've gone too far. So this is sort of like a countdown from 10 to 1. If I wanted to include 0, then I would simply give minus 1 as the value that's one too far in my countdown. Okay, so I think we've pretty well beaten list conversions to death. Any questions? All right. So next, let's take a look at, sorry. Well, I already showed you this one example of creating a list by using a set as the iterable, and if I have a set that's just one item, that's fine. In fact, you can create an empty list from some other empty iterable. Here, the open close parentheses is an empty tuple, and consequently, I'm creating an empty list by saying M12 gets a list converted from an empty tuple. What if I say M12A gets list 7? So, is that going to give me a list of one item, the 7? This is a trick question. How do you create a one-item tuple? You got to remember that comma, right? So if I say list parentheses and then I say parentheses 7, thinking to myself that I've created a tuple containing 7, actually I haven't. I've just created an integer value 7. So those inner parentheses essentially just get peeled out, and I get this mysterious error message. Int object is not iterable. What does it mean? Well, what it means is I forgot my comma. Okay. And so that works fine now. I do have a list of one item created by converting a tuple of one item. All right. Well, set conversions work in very much the same way, except that I use the function set to do my conversion instead of the function list. And here, if I convert, let's say, this list of 3s into a set, well, a list is iterable, so that's fine syntactically. A set will not allow duplicate values. It won't raise an exception if you provide duplicate values. It will just ignore all the duplicates. And so S2 here is a set just containing the value 3. Okay? And here's a very similar example, just using a tuple instead. So if I say S3 gets set from a tuple okay, it can be a little confusing looking at that. You have to remember that these outer parentheses here are for the function call. These inner parentheses here are for creating the tuple. And that works fine. And so I have a set containing these 5 items in no particular order. Just as with a list, if you forget that the argument has to be an iterable, and instead you attempt to provide just a sequence of values, then that will raise an exception, and Python will yell at you. And if you don't have an accept and you do this in a program, your program's going to die. I can create a set from a range just fine. So if I want a set containing all the values from 0 to 7, getting a set from range 8 will do the trick. And then we have tuple conversions, which really are just the same as list conversions and set conversions. So there isn't really anything too interesting to show here. If I say T2 gets a tuple built from this list, 3, 3, 3, that will do the obvious thing. It will create a tuple containing 333. If I create a tuple T3, on the other hand, from a set containing 333, well, here remember that the set is only able to contain one unique item of each value, so the set is going to collapse down to just the value 3, and then I'll get a tuple from the set containing 3, so now I have a tuple just containing a 3 with our friend the comma to remind us that this thing is a one-item tuple. Okay, if I just try to give values, I get yelled at just like I did with list and set. And if I use some part of a dictionary as my iterable, that will work fine. So I still have my N to S dictionary, and if I say T4 gets a tuple from N to S dot keys, now I have a tuple of the keys, and if I say T4A is a tuple N to S dot items, I have a tuple of the items. I have a tuple of two tuples here. So my tuple contains two items. The first item is a tuple containing the key and the value for the first entry in the dictionary, and the second tuple is for the second item in the dictionary. By now you're probably detecting a repeating pattern. Any questions? All right. Yes, yes.
And sorry if this is a really basic question, but can we review the definition of iterable? Yeah.
Okay. An iterable is the simplest way to define an iterable is, I mean, there must be a oh, there is actually. Okay. I had to dig deep. Okay, so there are internal methods within collections. One called iter, which gives you back an object that you can use as an iterable. And another one called next that will get you the next value from that iterable. So the technical answer to your question is, if the collection provides an iter method and a next method, then it is an iterable. But less formally and probably more meaningfully, it's like a sequence of things that you can step through in a for loop. So a string is an iterable, a range is an iterable, a list, a tuple, a set, the dictionary keys, the dictionary values. These are all examples of iterables that you could use in a for loop to step through the individual items. So as opposed to worrying about, does my thing have an iter function or not, experimentally you can just try using the thing in a for loop, and if it works, it's iterable. Okay? Other questions? Yes?
Following up, you said that the keys and items are all iterable. So is that this dictionary also iterable?
I didn't quite hear the last part of your question.
In the dictionaries, keys and items are iterable. So is dictionary also iterable?
Yes. Okay. So the dictionary is iterable, and what you get by default are the keys. Then the dictionary.keys are iterable, the dictionary.values are iterable, and the dictionary.items are iterable. So you've got 4 different iterables that you can use for gaining access to various pieces of the dictionary. And empty things are iterable. So I can say for x in an empty list, print x, and that doesn't print anything because the list is empty. I can say for x in an empty tuple, print x. And again, nothing happens. I can say for x in curly braces, print x. What did I just do there? What kind of thing am I iterating through? So an empty pair of curly braces represents what? Not a set. A dictionary, yes. How do I iterate through an empty set? I have to use the conversion function with no argument. Okay, so empty square brackets is a list, empty parentheses is a tuple, empty curly braces is a dictionary, and the empty conversion, the empty set conversion function with no argument is how you get an empty set and how you see an empty set if it's displayed on the screen. Other questions? Okay. So dict conversions are a little bit of a problem because in order to construct a dict, you have to have both keys and values. And a list, only has single items in it. A set only has single items in it. A tuple only has single items in it. So how can I get a dictionary built out of things like lists and tuples and sets? Well, I might try saying, give me a dictionary from a set and I might look at that and think, well, that makes sense to me. What I really want to do here is I want to set up the keys 1, 2, 3, 4 and just have some kind of default values associated with those keys, but no. No, it's not allowed. So I might decide, well, okay, it must require two things. Let me give my list for my keys, and let me give A, B, C, D. Okay, so the list is iterable, 1, 2, 3, 4. The string is also iterable. I'm going to get back the one character substring A, and then B, and then C, and then D. And I think, well, to me this makes sense. I'm going to have the keys 1, 2, 3, 4 with the associated values A, B, C, D. But again, no. So a dict, just like these other conversion functions, requires one argument, which does have to be an iterable. But the question is, well, okay, what kind of iterable can I give it that will make it happy? And it turns out the answer is you have to give it an iterable on pairs of values. And if you look at the documentation says that you have to give a tuple of two tuples. So that's what's going on here on slide 16. I'm saying D4 gets a dictionary built from a tuple of two tuples. All right, so here's my first tuple. So A is my key, 2 is my value. Here is my second tuple. B is my key, 5 is my value. And here is my third two tuple. C is my key, and 9 is my value. All right, so we've got 3 levels of parentheses nesting going on here. The outer parentheses are the function call parentheses. The next set of inner parentheses is creating a tuple. And the items within that tuple are themselves tuples. And each one of these tuples that the outer tuple contains is called a two-tuple because it has two values in it. And this does give me what I want. It gives me a dictionary in which A, B, and C are the keys, and 2, 5, and 9 are the values associated with those keys. All right, so that is literally a tuple of two tuples, which is what the documentation says that the conversion function wants. But really, all it wants is an iterable on pairs. And so I could say d5 gets dict and create a list of two lists All right, so here are my parentheses for my function that I'm calling. Here are my outer square brackets because I'm creating a list. And within that list, I have lists that each contain two values. And what I have here is an iterable on pairs. And so this will work for creating a dictionary. D5 is a dictionary mapping these integer keys, 2, 5, and 9, to the values 1.5, 0.42857, blah, blah, and 0.123. Yes?
They have to stay the same type all the way through, so 2, 5, 9, did you add another key that's an A, for example, a string?
I bet they don't have to be. Now, I'm glad you asked that. I've never tested that, but I bet they don't have to be the same types. I bet I could say, give me a dictionary from a tuple containing a list of two items and a tuple of two items and a set of two items set of two items Okay, so the outer parentheses here are for my function call, and within that function call I'm defining an iterable, so the next inner set of parentheses are my iterable, and within the iterable I have a list of two items, a tuple of two items, and a set of two items, and I bet that will work fine. Yay! Good. So the key 1 is associated with the value 2, the key A with B, and the key false with true. And the only rule is that the keys have to be distinct and hashable. An integer, a string, and false are hashable, and they're obviously distinct from each other. And then the values can be anything that I want. Any other questions about this dict conversion? Yes? Oh, excellent question. I'm glad you spotted that. Cool. Excellent. In a set, the order of the items is not guaranteed. And so it turns out on this system, if I define a set containing true and false, well, let's think about this. Let me create a different set. 3, 7, 5, 1, 8, 9, 2. If I create that set, what have we observed about this implementation of the Python shell? How is that going to be displayed to me? Probably. Even though it's not guaranteed, how is that going to be displayed to me? Probably. In ascending order. Okay, so that's not guaranteed, but that's how this implementation behaves. Now, if I ask, what is the integer value of true? That's a 1. What is the integer value of false? That's a 0. And so if I create a set containing true, false, 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 true, true, false. Well, first of all the duplicates are going to be thrown away, so the only values I'll have left are a true value and a false value. And this particular implementation of the Python shell, by default, when I create the set, puts the items in order, and so they come out false, true. So very good, very good, very good eyes. So even though I wrote my set up here as true, comma false, the implementation of the set on this shell reversed the order of those two things, and so I ended up with false as my key and true as my associated value. In other words, I was dumb. Questions? Okay. Okay. Excellent. Good questions. Okay, so we saw that you can use a tuple of two tuples, which, if you look at the official documentation, is what claims to be required. But you can also use any iterable on pairs. There's a function called zip, which is really nice, because what zip does is to zip together two distinct iterables to create a sequence of tuples on those. All right, so if I say, let's see, let me go back a bit, back up here somewhere. I said this. Let me create a dictionary in which my keys are 1, 2, 3, 4, and my associated values are A, B, C, D. All right? So the list 1, 2, 3, 4 is an iterable with 4 items. The string A, B, C, D is an iterable with 4 one-character substrings. So in theory, that kind of makes sense. But in order to get this to work, what I need to do is to use the zip function to zip those things together so that I end up with an iterable on pairs. So I end up with an iterable on 1A, 2B, 3C, 4D. This will work fine. And I have D2 defined to be the way that I want. To see what's going on, I could run this. I could use zip in a for loop to get a little deeper look at this. So I can say for x in zip. And I will see that zip actually produces 2 tuples. Okay, so zip produces an iterable on 2 tuples, which is exactly the kind of thing that the dict conversion function calls for in order to be able to build a dictionary. All right, so zip produces information in exactly the kind of format that the dictionary conversion function wants. Now, if you just look at zip by itself, you think, oh, well, I'd really like to see what this iterable thing looks like. So you say, show me what zip of these two things looks like, and it's not very helpful. You just get told, oh, well, that thing's a zip object. But you can't figure out what's inside the zip unless you iterate through it using something like a for loop. So far, so good. All right. So we've, yes.
So if one of the arguments of the zip function is a set, the results of the sequence of the results is randomly.
Yes. Yes. So if I do this, if I say zip 1, 2, 3, 4, and then I have a set of false, true, hello, 9. Okay, I've got 4 items in my list. I've got 4 items in my set. The items are unique and can be told apart, so I know that there are going to be 4 items in that set. But I have no recollection even of what this shell does, what this Python environment does as far as creating the order of those objects in the set. So when I hit, well, let's throw this into a dictionary to see what we get. D3 gets dict of that zip. I have no idea which of these values is going to be associated with each key. I do know that the keys are going to be 1, 2, 3, 4 in that order. But I don't know which of these values is going to be associated with each of those keys. All right, well that was just dumb luck. All right, that was just dumb luck. Because I think it appears that, let's see, if I create a set containing 15 and hello, maybe by default the string gets put first? Yes. All right, so so this was just dumb luck. Because false comes out ahead of true. Then apparently strings come out in preference to integers. Let me just do another example to prove absolutely that there's no way of predicting this. I'll get rid of false here. And I'll say 7.75 false. And let's see, so now I better have keys 5 and 6, let's say. Okay, now when I hit enter and look at D3, okay, I got false first, true next. Now this is strange. I got an integer followed by a float. Oh no, that makes sense. I got 5 ahead of 7.7, ahead of 9, but then I got the string at the end. All right, so it's even not consistent. It's even not consistent in what we saw before, where it put the string ahead of the integer. Here it's putting the numbers ahead of the string. So, all right, so I guess we flogged that one thoroughly enough. Any questions? Any more questions, I should say. All right. Well, in the second part of this chapter, we're going to take a look at. Oh yes.
So like it's really open that that in different environments the order each time will be different. So the match dictionary pairs the order will be different.
The best way for me to say it is that the order of items in a set is unknown. Whether you're going to get the same unknown order on your system as I get on mine, whether you get the same unknown order in Spider that you get in Idle, that you get in Jupyter, that you get on a Mac, I don't know. You know, there's just no way of telling.
I would agree on the material that the order in the set is dependent on the hash value of that value.
That's well, but we know that that's not true, right? Because we've had situations. Let me show you. Let me remind you. If I say S1 gets 1, 2, 3, 4, 5, 9, and S2 gets 3, 5, 7, 4, 1, 12. All right, so S1 is coming out in order, S2 is coming out in order, but if I ask for S1 minus S2, all right, that came out in order, S2 minus S1, not in order. So it's not predictable. It's not defined. Yeah.
So why the hello ranks the last one, the rest the last instead of ranks first?
Because it's undefined. It's like, I mean, it's undefined what's going to happen. And we can do experiments and we can make estimates about what is happening on our system, but the few experiments that I did here demonstrated that I don't even know what's going on this system. It's like, you know, if I have 5 dice and I roll them and I get 5 sixes, why did that happen? Well, it was just luck. Okay. Other questions? Yes. Excellent. Good question. It turns out what happens is that the shortest one determines the result. So if I say M1 gets 1, 4, 7, 1, 4, 3. Well, I should have different values here. All right, so there I've got a list of 7 values, and here I've got a string. This is a test. And my string has 14 values in it. If I say for x in zip, M1 and S1, well, since S1 is longer than M1, the trailing part of S1 is just going to get ignored. And when I print these, I only get as many individual values from the string iterable as there were values in the list iterable. Other questions? Okay. Well, now we're going to take a look at comprehensions. Comprehensions are intended to be a clear and concise and compact way of defining things like lists or sets or dictionaries, and it's often referred to as a Pythonic thing. As far as I can tell, Pythonic means cool. Pythonic also means, in a sense, that it's a syntactical mechanism that Python provides that other languages don't provide. So this is definitely something that Python provides that I've never seen in quite the same form in other languages. So, if you're going to be a Python programmer, you have to know about comprehensions. You have to use them all the time, even if they don't make sense. Okay. So let's take a look at a comprehension. Or let's motivate why comprehensions are a good thing. If I say M gets 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, I have created a list of 15 values from 0 through 14. What if I needed a list of 10,000 values? I don't want to do this, right? I don't want to type that out. Now, this is a little bit of a cheat, because if I have any brains at all and I remember what we just talked about, I could say, give me a list, range up to 10,000, and I'm done. Okay, so I can use the list conversion function. And there's my list of 10,000 values, which apparently my computer is too weak to want to display. Okay, so I'm going to kill that off. There we go. All right, so that's the cheap way of getting a range of values from 1 to 99.99. The Pythonic way is to use a comprehension. Now, a comprehension is sort of like a loop. All right, so let me say M20 is an empty list, Did you see how slow that was? My poor shell is messed up. Let me restart my shell and hope that it speeds up. All right, so now it should have forgotten about all the data it used to know about. So let me create an empty list. And I can say for I in range 10,000, m2.append I, and that will clearly work, won't it? I mean, it's very obvious what's going on there. I'm starting out with an empty list, and I'm appending 0 and 1 and 2 and 3, and I eventually get to a list of 10,000 values. The deal with a comprehension, though, is that we put the for loop inside the square brackets that we used to create the list. So instead of having a loop that builds a list, we have a list that uses a for loop sort of to build itself. And that looks like this. M2 gets, let's say, J for J in range. And I'm not going to say 10,000 because I know that's going to mess up my machine. I'll just say 20. Okay, so in this notation, let me scoot that up a little bit higher. In this notation, the first thing I have in the square brackets is what's called my expression that I want to use for each value that's going to be created in my list. And following that expression, I have a for loop that is using some iterable to determine how many times, how many values there are going to be in this list, and also what the values of each of these variables j is going to be. All right, now this expression in front here can make use of that loop variable. So I'm using j in my expression. And so what happens is, for j going in value from 0 up to 19, in my list I'm going to put the current value of j. So I'm going to put in a 0 and then a 1 and then a 2 and blah 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 and then a 19, and that will create for me a list of those 19 values. There's a lot of flexibility here because I can say things like M2 gets, let's suppose that I wanted 20 zeros. I could just say 0 for I in range 20. Now the value of each item in the list is just going to be 0 for each of these 20 values. Or I can say M2 gets I times 2. Come on. Go away. Okay, so I've got 3 comprehensions here that are very similar. They're all using the same for loop for some variable in the range of 20, that is 0 to 19. But in the first one, I used the value of the variable for each item in the list. For the second one, I used 0 for each item in the list. And for this one, I'm using I times 2 for each item in the list. So what I've got now is a list of even numbers from 0 up to 38. Yes?
Is there any alternative way to do this like we add a date?
Sorry, I didn't quite hear the second part of your question.
Do you have an alternative way to do this? We return the even number in a range 20, we add if.
Oh yeah. I could do this. I could say M2 gets I for I in range 0, 42, All right, there's almost always multiple ways to accomplish what you want. So here I'm getting the value of I for I equals 0, then for I equals 2, then for I equals 4, up to, but not including 40. So I'm going to get the same list from that. Is that what you had in mind, or is, or?
Can we use if in this?
Oh, can we use if? You bet, you bet. Okay, good, good. I don't have examples in the notes, but let me show you how you can do that. So the general format for a comprehension is you have an expression at the front, then you must have a for loop following that expression. All right? If you don't have a for loop, it's not a comprehension. So it's the for loop that makes the thing a comprehension. All right, so this where I said list range 0, 40, 2, that created M2 as the same list, but that one is not a comprehension. So if you get interviewed by somebody who knows Python and they ask you a question about, write a comprehension that does thus and so, a comprehension is an expression followed by a for loop. Anything else is not a comprehension. Now, can you use an if? Yes, you can say M2 gets I for I in range 40. All right, so that's going to give me all the values from 0 up to 39. If I mod 2 is 0. So here I've put an if following my for loop, and I'm saying if the current value of I is evenly divisible by 2, then I want it to be part of my list. Otherwise, leave it out. And so this gives me the same result. Question?
So there's no need to use the colon anywhere in the comprehension?
Well, I'm currently constructing a list, and so the list comprehension doesn't use any colons. Colons would imply that you're trying to create a dictionary, probably. And you can do that, and we'll get to that.
Okay, I just meant, like, I know normally we use colon, so I for I.
Oh, I see what you mean. You're asking me if I shouldn't have a colon right here at the end of my for loop.
Yeah, that would make it into a dictionary.
Yeah, and the answer is no. You don't put a inside of a comprehension. You don't put a comma. You don't put a colon at the end of your for loop. Yes.
So I'm just curious. Are comprehensions recommended practice for Python programmers? Or
Absolutely.
because it's a bit confusing to read. I feel it's a bit confusing.
No, this is easy to read. This is genius stuff. I'm a little skeptical too, but it's it's an extremely popular thing. No self-respecting Python programmer will actually use a loop. Yeah, you got to get used to comprehensions. It's something that you're expected to know and use. Now, after you get your job and have gained some good reputation, then you have some flexibility to do what you want. But this is the Pythonic thing. Okay? Someone else had a question? Yeah.
So like the more confused you get, the more confusing you get, the more comprehensive you get. Right?
The more Pythonic you get. Yes.
So like this, if one is more comprehensive than just following for loop, right?
Oh yeah.
I've got it.
Oh yeah. Yeah. I did not invent this, but I assure you it is heavily used, and if you want to do Python as part of your job, and somebody who knows Python asks you interview questions, almost certainly this will come up and you need to know it. and you need to think it's cool. All right? All right. So the idea of comprehensions is that they make it more clear that you're trying to develop a list, not that you're trying to run a for loop. All right? So the square brackets around the expression say, I'm creating a list here. I'm using a for loop, but I'm creating a list here. They emphasize what's important. And these things can be easy to read or not. You know, who knows? Here's another example that's worthwhile. I'm saying M22 gets I squared for I in range, let's say 1 to 11. 1 up to but not including 11. So I'm going to get a list of the squares of the values from 1 to 100. I like that one. It's pretty simple. It's pretty clear. You just have to practice with these things and use them enough. It's not even necessary to have single values in as your list items. I can call a function to generate a value rather than just having a variable value in my comprehension. So I have defined already, because I didn't want to have to manually type it in class, but I have defined at the beginning of this session the F to C function. All right, so, I restarted my shell, didn't I? Oh, well, all right, so I'll have to define it again. But it's easy, fortunately. So F to C is just 5/9 of times F minus 32. All right, so F to C of 212 better be 100. F to C of 32 better be 0. F to C of some reasonable temperature like 76 is going to be in the 20s in Celsius. And I can use F to C. I can use any function that's available to me in a comprehension. So here I'm saying M23 gets F to C of X for X in range 0 to 12 in increments of 10 to 13 in increments of 10. Okay, so 0 degrees, 10 degrees, 20 degrees, all the way up to 210 degrees, but not farther. I'm going to get M23 containing the Celsius temperatures corresponding to those Fahrenheit values. And that is pretty slick. I mean, it's very compact. Once you've done several comprehensions, it's very obvious what that's doing. I'm building a table of Celsius temperatures from Fahrenheit temperatures. And I can even create lists of other things. Here I'm creating a list of tuples. So M24 is a list where each item in the list is a tuple of I to the I to the power of 1/3 followed by I to the power of 1/2. Now I could either say 1/2 or I could just say 0.5 since that's a finite representation. And then I squared and I cubed. Okay, so each item in my list is going to be a tuple of these 5 values, the cube root, the square root, the value, the square, and the cube. Yeah.
X and range for the temperature, it wouldn't go up to 213 or to 212, stops at 210.
It stopped at 210 because my increment was 10. So it goes 0, 10, 20, 30, and when it gets to 210 and tries to go to 220, that's beyond 213. So far, so good. Okay, so I'm going to do this for I in range 1 to, but not including 11. So I'm going to get the cube roots, the square roots, the value, the square, and the cube of the value from 1 through 10. Okay, so every power of 1 is just 1. And here I have the cube root, square root, value, square, and cube of 2, etc. Okay, so these list comprehensions can be quite elaborate and create quite elaborate collections of things. So far, so good. Okay. Now, a set comprehension is exactly like a list comprehension, except that you use curly braces because you're defining a set rather than using square brackets as you require for a list. So if I say, let me do this. I'm going to import random, which is a random number module that's available in Python. And random has a nice facility called randint that lets you specify a low value and a high value. And randint generates, with equal probability, some value in that range from 1 to 10. Okay, so I got 7 that time. I got 6. I got 7 again. I got 3. Okay, so it's a pseudo-random number generator. I can't say whether its quality is good or not. Yeah?
So this is the rand int it's the same as the rand at. I will not get 10 minutes something like
The bounds here, if I understand your question,
yeah.
include 1 and include 10. So it's from 1 up to and including 10.
So it's different from function rand, right?
You mean like in a C program, or?
No, I mean the range 1, comma 10 is 2 to 9. It's 1 to 9.
Oh, okay. I think you're talking about NumPy's rand function.
No, I mean what's the bound of this function?
The bounds are what you specify. There is not a built-in rand function that I'm aware of. Is there one in the math module? I don't think so. But if I say import NumPy, and we're going to do this Thursday, then there is a rand function I think it's called randint, where the bounds are, if I say 110, it means from 1 up to 9, not 1 up to 10. NumPy, no enter. Oh, duh. I have to say np.random.rand 1, 10. All right, so rand is actually giving me floating point values in the range from 1 up to but not including 10. No, I'm mistaken. In the range from 0 up to but not including 1, and it's giving me 10 of those. There is a randint in NumPy And that gives me values between 1 and 9, not 1 and 10. So if I do this a lot, I should never see a 10. Whereas if I do plain old random.randint 1 to 10, notice what the documentation says here. A random integer in the closed range, I can't highlight the comment, I guess, but it's a random integer in the closed range A to B. So yeah, so this can be confusing, is that the random module has a randint function that does not behave the same way as NumPy's random module's randint function. Aren't you all glad you know that? All right. So I was doing something. I'm confident I was doing something. Oh, yes, we're talking about set comprehensions. So if I say S gets X for X in range 5, well, range is just going to spew out values 0 through 4. So this is going to be a pretty boring set, 0, 1, 2, 3, 4. But if I say S gets random.randint from 0 up to 100 for X in range 10, let's say. Now, for 10 values, okay, X going from 0 to 9, for 10 values, I'm going to get a random integer in the range from 0 up to and including 100 into my set. Now, I might get a duplicate. It seems, well, I might get a duplicate. If I'm making 10 draws from the interval 0 up to 100, I might get a duplicate. Let's see what we have. Yeah, I must have gotten a duplicate there because the length of this set is 9 rather than 10. Cool. And if I try this again, maybe this time I won't get any duplicates. Yep, this looks like it has 10 items in it. Okay, so again, this is an example of calling a function to produce a value for each value in some range of values. And I can get even more, I can say S gets random.randint from 0 up to 2 times X for X in range 1 to 11. Okay, so what I'm doing here is X is going from 1 up to 10. The first value that's going to be in my set is going to be some value in the range 0 to 2. So it's either going to be a 0 or a 1 or a 2. The second value is going to be a 0 or a 1 or a 2 or a 3 or a 4, and so forth. So I have 3 choices for the first item in the set, 5 for the second item, 7 for the third item, and I should probably see, interesting, I do see more or less kind of ascending values here. But that's just luck, and if I do this again, I'll probably see something else. Well, for sure I'll see something else. There we had multiple duplicates. Okay, so that's examples of set comprehensions. Questions? And then finally, dict comprehensions are defined like list comprehensions or set comprehensions, with the important difference that the expression at the front of the whole thing has to have a key and then a colon symbol and then a value. Okay? So what I'm saying in that example is D20 gets J colon J squared. So that's my item, right? My item has a key and a value. So that's my item in the dictionary. And my items are going to be generated from j in range 1 up to but not including 11. So this dictionary, given an index, gives me the square. So if I say d20 sub 4, I get 4 squared. And if I say d20 sub 2, I get 2 squared. d20 sub 9, I get 9 squared. All right, so that dictionary maps each integer value to its square from 1 up to 10. Cool, I'm 2 minutes early. Any more questions? Yes?
Comprehension specific to building numeric answers? Can you build strings?
Okay, excellent question. No, I can say this. I can say M123 gets a list of hello plus string value of j, string value of random dot randint from 0 to 123 for j in range 20. All right, so what am I doing? I'm generating a list. Each item in the list is going to be the word hello with the string version of some random integer appended to it or concatenated to it, plus is concatenation for strings. And I'm going to get a list of 20 of these things. And so there I have a list of strings. Now, I'm curious, are there duplicates in there? M123.sort. I don't see any no, I thought I saw one, but I don't see any duplicates in here. Well, that's dumb. I should, well, of course, a list is not a set, so even if there are duplicates, they should appear. The length of this list is 20, so I have 20 values in there. But that doesn't tell me whether I do or don't have duplicates. Other questions? Okay. So I'm 50-50 between being excited at showing you comprehensions and being sort of appalled that I have to show you comprehensions. But they are something that you really do need to know if you claim to have any Python knowledge. Okay? All right, so that's that. Now, I did post the next homework, and the next homework only requires you to know what we did today. It doesn't require anything that we're going to talk about on Thursday or next Tuesday. It should be easier than the one that you're currently finishing up. And so I have made it due on Tuesday rather than on Thursday. Okay? And I will see you on Thursday.